Let's take a look at another example. This example says solve the second order differential equation, y double prime minus 3y prime plus 2y equals to e to the power negative 4t, and y at 0 is equal to 1, and the y prime is just 5. So we have an initial value problem here. So for this initial value problem, we're going to take the Laplace, then simplify that as much as we can, then use the inverse Laplace. Laplace of y equals to the Laplace of e to the power negative 4t. So remember that for this one, we already defined it as to be s squared f of s minus s f of 0 minus f prime of 0. And here we have minus 3. Again, we have a definition here, s f of s minus y0. We're just going to copy this down, plus 2, and the Laplace of y is f of s equals to, here on the right hand side, we have the Laplace of e to the power negative 40, which is just 1 divided by s plus 4. Very well. So let us simplify this as much as we can. F at 0 is 1, so this guy is just 1. F prime is 5, so this is 5. And this is just 1 again. So it becomes s squared f of s minus 5 minus 3s f of s. And here we have plus 3 plus 2 f of s, which is equal to 1 over s plus 4. Okay, let's see, what do we have? We have s squared f of s, and we have another f of s, another one. So let's factor out f of s. It becomes s squared minus 3s plus 2. And here you have, let's see, negative 5 plus 3, which is negative 2, minus s minus 2 equals to 1 over s plus 4. Let's simplify this as much as we can. F of s, we're trying to isolate f of s on one side, s squared minus 3s plus 2, 1 over s plus 4 plus s plus 2. Well, this becomes f of s equals to 1 over s plus 4 times, here we're looking for two numbers, the multiplication is 2 and their sum is negative 3, so s minus 2 and s minus 1, and plus s plus 2 divided by s minus 2 times s minus 1. Very good. Here we can take the common denominator between these and combine the numerators. Pure algebra, f of s becomes, well, here you have, so you multiply this guy by s plus 4. So here you have s plus 4 divided by s plus 4, and you get s plus 4 and s plus 3. So you get s plus 3 times s plus 4 divided by s plus 4, s minus 2, and s minus 1. Very good. Let's see if we can simplify this more. And you get plus, just multiplying these. So here it stays 2 and plus 1. Okay. So this guy becomes f of s equal to, we get s squared 4s plus 2s 6x plus 9 divided by, here we have s plus 4, s minus 2, s minus 1. So note that our job is to write this as partial fraction, so we can easily take the inverse of Laplace transformation and calculate the rest. So let's see what we can do here. We can write it as, let's see, let us try to use the partial fractions So this becomes at a over s plus 4 plus b over s minus 2 plus c over s minus 1. So a times s minus 1 times s minus 2 plus b times s plus 4 s minus 1 and plus c times s plus 4 times s minus 2 can be written as a times s squared minus 3s plus 2 plus b times s squared minus s plus, so we get plus 3s minus 4 plus c times s squared minus 2s plus 4s plus 2s minus 8 equals to this quadratic expression up there. So it seems that s squared times a plus b plus c is equal to 1 squared. So it means that a plus b plus c is just 1. And then here we have negative 3a plus 3b plus 2c is equal to 6. And then we have 2a minus 4b minus 8c equals to 9. Very good. Now we have to try to take these 2 by 2 and solve for the missing variable. So let's see what we can do here. Here, if we divide this by 2, we get 2a minus 2b minus 4c equals to 9 divided by 2. What else do we have? So if you multiply the second one, or just multiply the first one by a negative a, negative 1, negative a minus b minus c is negative 1, and taking the last one, a minus 2b minus 4c is 9 over 2, we get negative 3b minus 5c equals to, well, 7 over 2. So far we have this one, and at the same time, so we took 1 and 3 and we wrote this way. Now we can take, for example, let's see, we can take 1 and 2 and make some adjustments here. We can multiply this by 3a, 3, so we get 3a plus 3b plus 3c equals to 3, so we get negative 3a plus 3b plus 2c equals to 6. So these two, they get canceled out. And then what we have 6b plus 5c equals to 9. So far we have these two system of equations. 6b plus 5c equals to 9. So you can cancel out these two. What do you get? You get 3b equals to 25 over 2, or b is 25 over 6. If we are not mistaken, we already found our b. So let us plug that in, for example, this equation that we have. I'm going to copy this guy down here. So we have 6b plus 5c equals to 9. I'm going to copy down 25 over 6 here. So you get 25 plus 5c equals to 9. For 5c becomes 9 minus 25. So you get negative 16. So c is negative 16 divided by 5. So we found b, we found c. Now we can use the first equation to find a. So let me just erase these. So a becomes 1 minus b, 25 over c, minus c, which is plus 16 over 5. So if we take common denominator between these, which is 30, we get 30 minus, let me see, 125 plus 96. Okay, let me simplify this. Here you get 126, you get negative 1 over 30. So A becomes negative 1 over 30. The part of using the partial fractions, it takes a little bit of time, but eventually we're able to simplify the whole thing. So this partial fraction is written as A, which is negative 1 over 30, plus B, which is 25 over 6, plus C, which is negative 16 over 5. So this is your f of s. So f of s is written this way. Now our job is to find the solution. To find the solution, y of x is equal to, well, here you have negative 1 over 30, the inverse Laplace of 1 over s plus 4, and plus 25 over 6, the inverse Laplace of 1 over s minus 2, plus negative 16 over 5, the inverse Laplace of 1 over s minus 1. So y of x is negative 1 over 30, and e to power negative 4t. And here you have plus 25 over 6, e to power, well, here you have 2t. And finally, we have the last term, which is negative 16 over 5 e to power just t. So we found a solution for this differential equation using the Laplace method.